Good day, class. In this lesson, we will learn to solve triangles, particularly using the law of sines. Notice how we have two triangles here. On the left, I insist that we have a right triangle, and notice how we'll see the right triangle indicator. That means we have a 90-degree angle there at that corner. On the right-hand side, there's no indication whether or not we have a right triangle. So here is the difference with respect to solving triangles. You want to know whether or not your triangle is a right triangle or some other kind of triangle. Either way, please note that with a right triangle or maybe an isosceles triangle or acute triangle, you're going to have labels that are orderly, if you will. So notice how on the left I've labeled angle A opposite side A. And so that can hold true for my right triangle as well as my triangle that is not a right triangle. And so I have angle A opposite side A. Also, I'll do the same with angle B and side B. Those will be opposite each other no matter what kind of triangle with which we're working. And also angle C and side C. Those are going to be opposite of each other. So anytime you're orderly, then you can proceed and be able to solve the triangle. That is to find every measure of all sides and all angles of that triangle. So let's take a look at how the law of sines is important. So we're dealing with the law of sines when we do not have a right triangle, or we're not aware that we have a right triangle. We have no indicators that we have a right triangle, and so we can't rely on some of the facts that we know about solving right triangles. So the law of sines says that the sine of angle A divided by the length of side A is equal to the sine of angle B divided by the length of side B. And it also says that those are equal to the sine of C divided by the length of side C. So all of these measures are equivalent to or the sine of those angles divided by the length of the sides are equivalent in any triangle. And so this has been discovered, it has been proven. Maybe your textbook, depending on what textbook you're using, can demonstrate how this is a fact. So we'll move forward with it and use it as another tool that we have in our tool belts with respect to solving triangles. So here's an example. We have a triangle. So of course there are three sides and three angles. And so I can see that I have angle A is unknown, but apparently angle B and angle C are known values, 60 degrees and 100 degrees respectively. And then we also have side A is unknown. It's opposite angle A. It is unknown. Side B is opposite angle 60, which is angle 60 is also angle B. That is, side B is unknown, as well as with respect to side and angle C. Those are 6 units in measure and 100 degrees in measure respectively. So we have some information and other information is missing. Now recall with right triangles, when we're missing lengths of sides, we can use the Pythagorean theorem. But of course here, not only do we not have enough side length information, but we don't have any indicators. In fact, we know that this is not a right triangle. So then we can't use it. So we move forward. One thing we can use is the notion that, or the fact even, that all the angles, interior angles of a triangle add up to 180 degrees. So with that information, we can go ahead and determine that the measure of angle A is 20 degrees. So the more information you can pull immediately, let's go ahead. I'm going to go ahead and replace that angle A with a measure of 20 degrees because now I know it's angle A. It has a measure of 20 degrees. And so here we're thinking, okay, maybe I can use the sine of theta, or the sine of the angle, sine of X, sine of A, however you want to call it, is equal to opposite over hypotenuse. But remember, that belongs to right triangles. Those are the facts that represent and that govern right triangles. And see, we don't have a hypotenuse, so this is going to have nothing to do with the sine of an angle is equal to opposite over hypotenuse. So we'll throw that out and we'll go with instead the law of sines, where sine of angle A divided by the measure of side A is equal to the sine of angle B divided by the measure of side B is equal to the sine of angle C divided by the measure of side C. And so with that information, I'll know what do I have, what information do I have that I can work with in this situation. And so I notice that I have information about side C and angle C. So with that, I'm going to move forward with the measure of, with those two, at least those two elements, sine of C over C, sine of angle C divided by C. And then whichever one I want to solve for first, the sine of angle B over the sine of side B. And so I'll go with that, those two, and substitute my variables, my unknowns, for my knowns when they are known. And in this example, you should have a single unknown. Of course, we're not able to solve an equation to its conclusion unless we only have one unknown. And in this case, we know the measure of angle B. So the sine of 60 degrees divided by the variable B is equal to the sine of 100 degrees divided by 6. Because those are the measures that represent the sides and angles of B and C. And so I'll simplify. I'll cross multiply actually and divide, and so you should be able to reorganize your equation that says the measure of side B is equal to 6 times the sine of 60 divided by the sine of 100 degrees. And so with that, we can go into our calculators, make sure our mode is set to degree mode, and we can simplify and so, or solve. And remember, I've rounded the value of the measure of the length of this side. So B is approximately 5.28 units, whatever units this might be, feet or miles or what have you. So I'm going to replace that measure. Now I'm getting closer and closer to having the triangle solved and all of the details. So with this, I'm going to move forward again with my law of sines and substitute the values that I know. I can be selective here. I can decide which measures I want to use because now I have B, the information about side and angle B, but that's okay. I'm going to go with, I choose to go with A and C here. This is a creative process, so you get to choose whichever measures you want to go with, and then I substitute those values. The same thing, I'm going to cross multiply here, and I now have A is equal to, or side A is equal to, once I round that, it's approximately 2.08 units in measure. So now that you know how to solve a triangle, whether it be a right triangle or a non-right triangle, you also need to know about one caveat. The law of cosines is how we overcome this particular caveat. Notice here, I am given side measure C, but not angle measure C. I'm given side measure, angle measure A, but not side measure A. And I'm given side measure B, but not angle measure B. So whenever that happens, you do not have corresponding side and angle measures anywhere, then you cannot or you will not find any success trying to use the law of sines. In that case, you will employ the law of cosines. And if you take a minute to study these three formulas, you will discover that they are very rhythmic and that there is a pattern that exists here, but you will select your formula based on the most relevant to your given numbers, your given measure, side and angle measures here. And so here I can work with that B and that C and solve for my A. So here I'm going to use the A squared equals B squared plus C squared minus 2BC times the cosine of A. I'm going to substitute those values into the formula as given, and I'm going to solve. Don't forget, you take the square root of both sides to get A by itself, and then you discover that A is approximately, again, I rounded this, 6.04 units in measure. Remember, you use the law of cosines if you have no matching corresponding relationships between your sides and angles.